Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
And thanks to everyone who has decided to join us here today. Special welcome to anyone who's joining us for the first time. Certainly glad to have you here. If you've been here before for one of our webinars, we certainly appreciate you coming back to watch us again. Just want to make a point that we do our best to provide information in these webinars on a every couple month basis. And we're trying to provide information that you guys are going to find at least interesting, if not captivating. And so if you have some ideas as to what that might look like for you, please let us know. And I can't promise you that we'll be able to incorporate all that into future webcasts, but we will certainly do our best to try and make that happen. So with that said, let's move on to today's presentation, which I've entitled, "There's Nothing Ordinary About Extra Hazard." Hopefully you can all see kind of what I did there. Ordinary, extra. Okay. Okay, we move on. So if you're watching this presentation, you might have a few questions. That's kind of what I'm thinking. So the first question you might just actually be asking is, George, seriously, you're going to do a whole presentation on extra hazard. And maybe question 1A is, why now? Why would you want to go down that route now? And I guess what I would say is, when we look at some of the things that have changed in the marketplace, and we're seeing some recently expanding opportunities for contractors to take advantage of. And so we want to make sure that we're making you aware of what some of those changes might be. The second question you might be asking yourself is, but is extra hazard design really any different? And I guess my answer to that would be that at the end of the day, sprinkler design is sprinkler design, right? We have to worry about spacing and hydraulic calculations and all that kind of thing. But at the end of the day, there's some nuances to extra hazard systems that if you don't take care of and you don't make sure that you incorporate into your design, you can get you in a little bit of trouble. And then the third question might be, well, is there really anything new to talk about? I guess what I would say there is that, classification and design in a lot of those manufacturing situations remains the same, but in some cases, some of those things have changed. And so we want to make sure that we are making you aware of what some of those changes are. And then the last question might be, what specific sprinkler should we consider using in those applications? If you're used to doing standard light hazard or residential or ordinary hazard work, what you're going to find is that there's going to be some changes in K factors and some different sprinklers that you may want to use when you run into this extra hazard environment. Okay. All right. So if we go back and we look at manufacturing construction, and this is a chart from the U.S. Treasury Department that shows what it's done over the last, let's say 20 years or so, right? And what you're going to see is right around 2011, we had this drop where it dropped down to about 50 billion in construction dollars a year. But from about 2015 through about 2021, you can see that it was pretty flat line. We get up to about maybe 125 billion in 2015, and we kind of stay along that line all the way until 2021. And in 2021, something happens, and all of a sudden, what we see is that suddenly we've had this massive increase in dollars spent for manufacturing construction. And what we've gone from is something in the neighborhood of about 90 billion to numbers that exceed about 190 billion in manufacturing construction. Now, maybe one of the questions might be, well, is that limited to the US? Well, there are countries internationally that have seen some of that growth. If we look at the UK and Australia, we can certainly say that they have seen some of that growth, but nobody's seen this rapid rise in construction dollars on the manufacturing side like the US has. So if we take a look and we try and figure out where that growth comes from, there's a couple places that we need to look. And I think one of those things that you're going to see is if we look at some of that growth is certainly from government legislation. Okay. So the first thing that we want to talk about is the IRA, and that's not like, what you're putting in your 401k, and that's not like, we can argue what it really is, right? It was called the Inflation Reduction Act, and we can discuss whether it really did anything to lower inflation. But what we do know is it resulted in a lot of dollars being spent for clean energy. Okay, that might be solar, that might be EV, that might be a wind, but there were a lot of dollars that went into that legislation that, again, reflect on the manufacturing side. Okay, and then the second thing we might want to talk about is the CHIPS Act, or the CHIPS legislation. And CHIPS stands for Creating Helpful Incentives to Produce Semiconductors. So essentially, if you're in the semiconductor business, you've been incentivized to go out there and increase your manufacturing capacity. So are those the only areas that have been strong? Well, I would say there are other areas that have been strong as well. So if we look at things like chemical manufacturing or transportation or food and beverage, we're going to see that in those scenarios, those markets have stayed relatively strong and even showed a little bit of growth. And then maybe the third thing that I think, we need to consider when we talk about that growth is this idea of an expanding supplier network. I mean, if we all go back to our pre-COVID days and we go back to the supply chain issues that people had, ultimately it produced this situation where people couldn't get what they needed. So they either had to find alternative sources for those products, or they had to go back to their existing sources and say, hey, you need to expand capacity so this doesn't happen again, right? So it put us in that kind of position where we had to make those kind of decisions. And so we've continued to see that kind of growth on the manufacturing side. All right, so when we talk about general requirements and we talk about extra hazard in general, there's two classifications for extra hazard. You got an extra hazard group 1, an extra hazard group 2, more commonly called EH1 or EH2, which I will probably resort to at some point during this presentation. Okay, but what you're going to see when you look at these is that first item, whether it's an EH1 or an EH2, that first item on the slide is the same: spaces with very high quantity and combustibility of contents. Right. So if it's highly combustible, we're going to move it from our standard category, ordinary hazard that we look at in most manufacturing scenarios, to an extra hazard application. And then the second thing that you're going to see under extra hazard group 2 is spaces where dust, lint, or other materials are present, right? And so there's this consideration of that versus when you look at extra hazard group 2, you're going to see a different classification under item 2, which is going to say areas with substantial amounts of combustible or flammable liquids. So I think that's the big differentiator when you go from an extra hazard 1 to a group 2. Extra hazard 1, for the most part, is going to incorporate things like particles and dust and fibers, right? And then extra hazard group 2, in a lot of cases, is going to be wrapped around this idea of flammable liquids. But the interesting thing that I found when I was kind of doing this, doing some research for this presentation, was this item number 3 under extra hazard group 2, spaces where shielding of combustibles is extensive. And I said to myself, I'm not exactly sure what they mean by that, right? So I went back to NFPA to see if there was any enhanced content that would give us a better understanding of what that actually was. And fortunately for us, there is, right? So extra hazard group 2 occupancy classification applies where ceiling sprinklers are obstructed by non-structural elements. So if we've got a lot of process piping or machinery or those types of things that we're using in this building, it can literally change the hazard classification from something that might be ordinary to something that might be considered extra hazard. So in that scenario, you want to make sure, if you are in the design world, right, that you're considering that might be an option if what you're finding at the ceiling is just well beyond what you've seen in other manufacturing environments. All right, so when we look at traditional extra hazard, and this is the chart that you see here is taken from NFPA 13 2022 edition, and these are kind of listed out in Appendix A. And so you're going to see in that first picture there, basically what that is it's an area where we've got a lot of combustible hydraulic fluid use. And then, then it kind of goes into kind of those areas that I was talking about earlier, like particle board manufacturing or plywood manufacturing, right? We're worried about particles and dust and that type of thing. Things like textiles, right? Because we've got fibers that we've got to worry about, and those kind of things that are going to be in the air. And so we've got this kind of highly flammable condition that comes with those. And then finally, upholstery with plastic foams. I mean, anytime we involve plastics in anything that we do in the fire protection industry, we know that we elevate the fire protection criteria dramatically. So if you're looking at upholstering with plastic foams, you're going to certainly see an area that is required to be protected in accordance with an extra hazard criteria. So how about extra hazard group 2? Again, the biggest distinction you're going to see is we've moved from more of a particle type situation to something that's a little more liquid. So asphalt saturating, what you see on the right there is a picture of essentially roofing products. So things that we use on the roof that use asphalt to do that. And so obviously when they get heated, they melt, and so that becomes part of the issue. And then things like open oil quenching, which is kind of a more traditional thing that we would expect where we would see an extra hazard environment. Okay. So I'm looking at the extra hazard group 1 and the extra hazard group 2, and I'm kind of doing a comparison in my own head as to all these categories and where they are. And it's kind of interesting. So what I did was I pulled out all my old NFPA categories, all my old NFPA 13 books, and I went back to 99. And essentially, if you look all the way back through 99, what you're going to see is there's been no change really in any of these categories. What was listed in 1999 is still listed in the 2022 edition NFPA. The one exception to that was car stackers and car lift systems with two cars stacked vertically. So that was the one exception that I found versus the 99 edition of the code. Now, I don't know if any of you were driving back then. I don't know if there was such thing as a car stacker back in 1999. So again, just to kind of wrap up where we are at this point. So when we look at extra hazard and we look at the characteristics of extra hazard, the first thing that you're going to see is, for the most part, it is going to focus on the manufacturing environment, right? It's going to be wrapped around that scenario. And there really are two considerations that we're going to take into account. One is the quantity and the combustibility of content. And then the second is going to be this idea of flammable liquids and combustible particles, right? So it's those two items that combined or independently are going to be what create this extra hazard situation that we run into. But what we are going to know is, in all those situations, at the end of the day, what we're really anticipating is that we are going to have very, very, very rapidly expanding fires. And that's the real consideration when we get to extra hazard. So that's kind of the traditional approach to extra hazard occupancies. And then, the question that I kind of had in my own mind was, what are we seeing in the marketplace now? What makes it a little different than what we used to see in the marketplace? And one of the things that I found, again, just doing a little research, some sections of H5 occupancies under the IBC code. Now, if you're like me, you're probably going, what the heck is an H5 occupancy, right? An H5 occupancy is a semiconductor facility, okay? Now, for the most part, when you are working in a semiconductor facility, you're going to see that it is largely ordinary hazard group 2, and that's the way NFPA is going to tell you to look at it. But there's a specific requirement when we get to storage rooms with dispensing facilities. And then, I don't know, maybe you guys, again, way smarter than me, but my question was, what the heck is a dispensing facility? What does that mean, right? So I do a little research, and what I find out is, if we're talking about a dispensing facility, we're talking about if it has equipment for weighing, sampling, filling, or refilling, then we call it a dispensing facility, which is pretty much every storage room is going to have that kind of equipment in it. So for the most part, even though there may be scenarios where you can use an ordinary hazard group 2 application for that, for the most part, I think what you're really going to find is that those areas are going to need to be protected in accordance with an extra hazard criteria. Another thing that we found out, we've done a lot of work, Reliable's done a lot of work recently in battery plants, primarily in formation and aging scenarios where we're using our LB11 to protect the storage component of that space. But what we found is in a lot of the clean rooms in those facilities, we found that there were also scenarios where those clean rooms needed to be protected with something that exceeded ordinary hazard. So now we've got to, we're looking at some kind of unique sprinklers to be able to protect clean rooms in battery plants because they also carry this extra hazard criteria. And then another thing, I don't know, anybody ever watch Storage Wars? Anybody ever check out that show? It's like, okay, mini or self-storage facilities, and you try and wrap your head around whether that's an extra hazard environment or whether it's not an extra hazard environment. And you can picture the guy unlocking the door and he opens it up, and in the corner there's like a little toolkit with a saw and a hammer. Certainly not an extra hazard environment in terms of protection, right? Definitely not an extra hazard environment in terms of protection. But sometimes when he opens up that door and he flings it open, you see mattresses stacked to the ceiling in those things, right? Everything jammed into a 10 by 10 space. And in those scenarios, it certainly could meet the criteria of extra hazard. So what we have in this situation is a lot of different scenarios where people are saying, you know what, we don't know what we're going to protect in this space. We don't know what we're going to have in this space. So to err on the side of caution, let's make sure that we're protecting those spaces in accordance with an extra hazard environment rather than an ordinary hazard environment, just to make sure that we're covering the appropriate hazard. And then, obviously something that's got a lot of press lately is this idea of parking garages. For the most part in NFPA, you're going to see that it's pretty much wrapped around an ordinary hazard group 2 criteria now. But there are a lot of municipalities that are looking at that and saying that's just not adequate. And it's certainly not adequate when we have EV charging stations within those garage parking areas. So if we're looking at cities like San Francisco, cities like Miami, there's been significant changes in the way they want those protected. And in that case, it's going to be a 0.4 density and it's going to be an extra hazard group 2 criteria. All right. So what about the design of those types of systems? What does that look like? Well, the first thing that we have to wrap our head around is this idea of smaller system area limitations. So if you're used to working in an ordinary hazard environment, you know that system size can easily, be 52,000 square feet. But when we're working in an extra hazard environment, those system sizes get smaller. And essentially what they do is they limit you to about 40,000 square feet for each system. And if you go through the notes in NFPA, it's going to tell you that those smaller limits have really been created to reduce the area that's affected when we do a shutdown. So in other words, if I have to shut down a certain portion of my building, I want as little of it as possible to be out of service at a time, okay? So that's the criteria. Now, that being said, what I have heard, and I don't know exactly where it's going, but I have heard in 2025, there's been a little bit of a push to extend what those limitations look like. So in the 2025 edition of NFPA 13, you may see a scenario where that 40,000 expands out to 52,000 square feet as light hazard or ordinary hazard is. Okay, what about hose streams and water supplies? Well, obviously, we're concerned about, extra hazard. We're concerned about rapidly developing fires. We also want to be concerned that we have the water, if the sprinkler system doesn't do its job, to be able to adequately help and assist in firefighting in those applications. So you increase your total hose stream increases from 250 in an ordinary hazard environment to 500 GPM in an extra hazard environment. And not only that, but you have to take into account a larger or a longer duration in terms of your water supply. So you've got a minimum duration of 90 minutes, a maximum duration of 120 minutes. Essentially, the difference between those two numbers is just whether or not that system's supervised. System's electrically supervised, you can go down to 90 minutes. If it's not, then you've got to increase it all the way to 120 minutes. So since we're talking about again, hazard classifications, or we're talking about bigger hazard classifications and more water, that becomes significant because in a lot of cases, when we get to these higher hazards, we have less water available from the city or lower pressures available from the city to be able to fight those fires. And as a result, we sometimes have to supplement water supplies, certainly with fire pumps, but sometimes even with water storage tanks. So those duration times are significant, because obviously if we're increasing duration time, we're increasing the size of the tank that's required to be able, that we need to utilize. So what about general design considerations? Well, if you're looking at, this chart that you're looking at here is actually from the 2019 edition of NFPA 13. And essentially what you're going to see is, if you're looking at light or ordinary 1 or ordinary 2, that you've got an area of a sprinkler operation that's limited to about 1,500 square feet. So we can pick a point anywhere on that curve, right? But for the most part, we're going to pick that bottom point on the curve, so that for an ordinary group 1, we could be at a 0.15 over 1,500. Whereas now look what happens when we go to extra hazard. That low point on that curve is no longer based around a 1,500 square foot operation area, but we've increased that area to a minimum of 2,500 square feet. And we've increased the density significantly. So if you look at ordinary group 2, you're talking about a 0.2. You're looking at 1.5 times more water for an EH1, and then twice the water actually for an EH2. Okay. Now, keep in mind, when we look at these, what you're going to see is that there used to be a time when we had these curves where you could move to a point along the curve. So if you wanted to be at a 0.24 over 4,000, you could do that and still be at a point on the curve where you could be considered in an extra hazard group 1 environment. Okay. In 2022, that all changed. 2022, we go away from this idea of curves and design curves to this idea of a single point density. And so now, if you're looking at an extra hazard group 1 or an extra hazard group 2, group 1 is going to tell you it's a 0.3 over 2,500. Group 2 is going to tell you it's a 0.4 over 2,500. And you are stuck with that criteria. There is some situations where you're going to work a little different. You can see where there's a second, that or there, that second point, as a result of the or there, is simply telling you that what's highlighted in red at the bottom. So if you have a design area of 3,000, you're going to have to apply a design area of 3,000 square feet if this area is adjacent to a combustible concealed space. Okay. So one of the things historically that we've been able to do, and especially when we live in that light hazard or that ordinary hazard environment, is this idea of being able to reduce the remote area. And as we all know, when we're working with a light hazard environment, right, we're going to use a quick response sprinkler, and as a result of using that sprinkler, we're going to be able to reduce that area from 1,500 square feet, maybe down to 900 square feet. In an ordinary hazard environment, same thing. If we go from that standard response sprinkler to a quick response sprinkler, we get the opportunity to reduce the remote area. Okay. But while NFPA allows that in a ordinary hazard world, right, that criteria is not acceptable in an extra hazard environment. So not only does NFPA say you can't use a quick response sprinkler to reduce your design area, but it says you can't use a quick response sprinkler at all. All right. So is there some other way for us to get there? Is there some way that we can reduce this remote area without dealing with response times of sprinklers? And there's a couple outs that NFPA gives us when we play in the extra hazard space. Okay. The first one is we can reduce the area up to 25% when high temperature sprinklers are used. So if you go from a 155-degree sprinkler to a 286-degree sprinkler in a particular environment, you can reduce your area, okay, by up to 25%. And I think keep in mind that term up to, right? And then if you look at 19.2.3.2.7, right, what you're going to see is that if you go to larger K factors, it also gives us the opportunity to reduce that area up to 25%. Okay. Now, I think that criteria was probably established back in the day when we actually used the 2019 edition of the code, and we could move up the curve substantially enough to reduce it by 25%, and that way kind of use that criteria. The difficulty is that the minimum area of design that NFPA tells you can use is 2,000 square feet. So again, if you take your 2,500 and you reduce it by your 25%, you're going to get somewhere around 1,875 square feet. In reality, NFPA is not going to let you take that total reduction anymore. It's going to force you down the road of a minimum design area of 2,000 square feet. Okay? So if I'm using standard coverage sprinklers, okay, there is still a scenario where I can use pipe schedule. But in this scenario, pipe schedule is limited to existing systems. So it's got to be an extension of an existing system. And it's been that way in the standard for really quite some time. And notice when we hydraulically calculate the system, it actually allows us to change what that spacing requirement is. So we go from a square foot spacing of 90 square feet if we're extending a system and doing it through pipe schedule versus being able to go to 100 square feet if we are hydraulically calculating that system. Now, again, there's this thing, and again, I don't know if this makes a whole lot of sense, but it says hydraulically calculated with densities at greater than 0.25. Well, if we're working under the 2022 code and we don't have the opportunity to move our way up the curve, we're always going to exceed that 0.25 density, right? Because it's always going to be a 0.3 or it's going to be a 0.4 if we're talking about an extra hazard group 2. And then look at what the maximum spacing is. It's going to limit your spacing for those sprinklers to 12 feet. Except in one scenario, and that scenario is where you have kind of that standard metal building scenario, and it's a 25-foot bay, and they're going to allow you to install sprinklers in that scenario on 12-foot 6 centers, so that you only have to install 2 lines of sprinklers in a bay instead of 3 lines of sprinklers in the bay. But that's kind of the one exception. All right, what about extended coverage sprinklers? What if I want to use extended coverage sprinklers in this environment? Well, there's 2 scenarios where NFPA allows me to do that. And those 2 scenarios are when I have unobstructed construction or when I have obstructed non-combustible obstruction. But in that scenario, in that second scenario, you've got to have a sprinkler that's specifically listed for that application. Okay. Notice when we get to obstructed combustible construction, there is no option to be able to use an extended coverage sprinkler for that application. All right, so that's kind of the NFPA world, and that's kind of what that design criteria looks like. In the manufacturing scenarios that we run into on an everyday basis, there are a lot of situations where we not only have to worry about kind of what NFPA wants to see, but we also have to worry about what FM would like to see in that application. So as you probably know, or if you don't know, essentially FM is going to classify hazards differently than NFPA does. NFPA is going to call it a light or an ordinary or an extra. FM Global is going to say it is either an HC1, an HC2, or an HC3. And in a scenario where this table exists, you're going to find this in data sheet 3-26. And then they're going to give you multitude of different occupancy classifications and specific examples of those applications when you get into tables in C1 and C2 of Appendix C. So you go into the appendix and you look, and there are pages of what their hazard classifications look like. So again, something that you might want to make sure that you're looking at before you get into the design phase of a project. So some examples of HC3, mattress factories, modular building assemblies, coating and printing, plastic factories, plastic goods, things that you would see if you were to go to NFPA and you were to look at NFPA and what they considered an extra hazard classification, and then you were to go to FM and see what they considered an HC3, I think you'd see a lot of congruity in terms of what that looks like, okay? But there's going to be other scenarios where that's not necessarily the case. So, for example, if you look at parking garages, NFPA recently made a move that said parking garages are going to be an ordinary hazard group 2. In the 2021 edition, FM was very specific to say if it's a parking garage or it's a repair garage, that we are going to consider that as an HC3. Okay, so package delivery and distribution hubs might be another thing. I personally remember back in the day doing some exhibition halls and convention centers, and depending upon the size of those exhibition halls or convention centers, they may have considered them an ordinary hazard scenario, or they may have considered them an extra hazard, depending upon what type of events they were going to have there. You know, if you're going to have a car show there, for example, they may want to make sure that they consider that an extra hazard environment. Basically, Factory Mutual says we don't care what size it is or what you're going to do there. If you're going to have that kind of facility, you're going to call it an HC3. Okay. And then there's also a scenario where they've just made some changes recently at NFPA to say if it's a desalinization plant, or if it's automobile manufacturing, or if it's any kind of battery manufacturing, recent changes to FM are going to say that those are going to be considered an HC3. All right. What about design criteria? What does FM say versus kind of what NFPA says? Well, again, if we look at that HC3 category, you're going to see that there's some uniqueness here, because while NFPA doesn't really take into account ceiling height or ceiling elevation in any way, Factory Mutual looks at it and says, well, depending upon the ceiling height, you may have to change the density that you're going to provide as far as your protection scheme goes. So again, if you look at their basic HC3 requirement, if they have ceiling heights that are 30 feet or less, they're going to tell you that 0.3 over 2,500, which is consistent with what NFPA requires, is good. But also look that when they go to dry systems, it's not like NFPA that's going to say, well, we're just going to do a 30% increase in the size of that system, which would take it to what, 3,250, if I'm doing my math correctly. They're basically just going to say add 1,000 square feet. So for a dry system with ceiling heights up to 30 feet, FM is going to say, well, it's got to be a 0.3 density, but you're going to take that 0.3 density over 3,500. And then what you're going to see is that increase of 1,000 square feet is pretty consistent regardless of ceiling height. But notice how dramatically your area of operation increases as you get into more height. If you go ceiling heights under 30 feet, 0.3 over 2,500, as soon as you get into those ceiling heights of 30 to 45 feet, you see that density goes from a 0.3 over 3,600. So a much, much larger area of operation that they are going to ask you to design to. Okay, and again, you'd find that particular sheet, you'll find in data sheet 3-26. One of the things that I found interesting is that the caveat to that is if you look at note 2 at the bottom, and I don't, hopefully I've made it big enough that you can actually see it on the screen, but it gives you specific criteria for HC3 occupancies, where ceiling heights are not in excess of 30 feet, and it allows you to take that area and make it smaller. I don't know that there's anything else, and someone correct me if I'm wrong, but I don't know if there's anything else that I saw in FM that allows you to shrink the size of that remote area. So if we go back to data sheet 2.0 or 2-0, what you're going to see is there's a couple other things that we have to consider when we look at FM versus what we would consider when we look at a standard NFPA design. And one is response time. So again, remember everything that I told you about quick response sprinklers and NFPA? Well, that doesn't necessarily apply when we get to Factory Mutual. Factory Mutual, you can see in each of those scenarios, whether it's up to 30, over 45, over 60, it gives you the option in most of those scenarios to use either a quick or a standard response sprinkler. The other thing that you're going to see that's different about NFPA criteria is when it comes to slope. So in the maximum slope in any NFPA environment is going to be a 2 and 12. Factory Mutual, actually, you can see where it gives you some opportunities to be able to go up to a 4 and 12 slope. So again, just to kind of summarize, okay, NFPA is going to tell you that we're going to use standard response sprinklers. FM Global is going to tell you can use a standard or a quick response in most scenarios. Okay. For the most part, you're going to use standard covered sprinklers with NFPA. You have more opportunities to use extended coverage sprinklers in a factory mutual world than you do in the NFPA world. Larger K factors for higher densities is always going to be the case. We can always squeeze more water through larger K factors. So we want to make sure that we're thinking about what that looks like from a design perspective. And then finally, again, don't forget this idea of slopes, where if it's an NFPA environment, your slope is going to be limited to 2 and 12. But when we go to FM Global, there are some sprinklers that are going to allow us to go up to 4 and 12. Okay. Now, there's always a caveat, right? So this is kind of the caveat for factory mutual. Even though they tell you that in most cases you can use quick response sprinklers, there are some scenarios where they say, no bueno, right? And so when you're looking at this, you're going to see that in areas where you have rapidly expanding fires that use flammable or ignitable liquids, you're going to see factory mutual say, maybe in that area, maybe we don't want to consider using a quick response sprinkler, and maybe you want to confine your design to standard response sprinklers in that application. All right, so those are some design considerations. Let's just talk really briefly about some sprinklers that you might want to consider in that environment. Okay. So you're looking at two sprinklers on your screen. One is just a bulb type F180. The other one is our Model G, right? 8K, both 8K sprinklers, both standard response, both UL/FM, both available in upright or pendant. But there may be a scenario here. Maybe you want to use an F180, and maybe you want to use an F180 because one of the things that we kind of hinted at is because we're talking about higher densities in these scenarios, we're also talking about higher pressure points, or maybe pressure in a water supply that's going to be higher. Well, in an F180 is UL listed for higher pressures all the way up to 250 PSI, whereas if you're going to use our Model G sprinkler, you're kind of limited to that 175 PSI realm. On the other hand, if you're looking at some kind of retrofit environment and you're looking to upgrade that system and you're looking for a sprinkler that has half-inch threads but is an 8K sprinkler, then that's going to kind of push you toward the Model G world, where now you're going to look at that and say, okay, well, if I don't want to rip everything out that I currently have at the ceiling, and if my spacing is such that I can use my existing pipe and fittings, maybe I can use a Model G in that environment with half-inch threads and an 8K sprinkler. So what else does Reliable have in the standard coverage? Now, these are all control mode density area sprinklers. The GXLO is an 11.2K sprinkler. The Model G Velo is a 14K sprinkler, and then the J168 is a 16.8K sprinkler. All of these use our Model G type capsule, and keep in mind that you do have some distinctions here in terms of what's available. So if you're looking at the GXLO and you want an upright or a pendant, that's not a problem. We manufacture that sprinkler so that you can use it in either orientation. The upright is UL/FM. Understand that if you're using the pendant, it is FM only. Okay, so keep that in mind if you're looking at design criteria. What about the G Velo? Well, it's only available as a pendant, but it is available both UL and FM. And then what about the J168? Well, now, again, the Velo is only available as a pendant. The J168 is only available as an upright. Again, UL/FM approved. Okay. Well, what about extended coverage? What do you guys have? Well, I'm glad you asked that question. Okay. We have our model N252EC. It's a 25.2K pendant only sprinkler. And here's kind of the unique thing. When you look at the listing of the sprinkler, it is UL listed as a standard response sprinkler, which means we can use it in NFPA requirements, in NFPA situations as a standard response sprinkler in an extra hazard environment. But it's for FM, it is listed as a quick response sprinkler. So it can also be used in those particular types of applications. You're going to see that it comes in both an ordinary temperature and an intermediate temperature. Your maximum spacing in this scenario is always going to be 196 square feet. So maximum spacing for this sprinkler is going to be pretty much 14 by 14. Available in a variety of different finishes. And interestingly enough, it's also available as a recessed sprinkler. And even though you can see, the availability from a recess perspective is only from a UL testing standpoint, we have seen scenarios because nobody else has a pendant that is at all listed for this application. We have seen Factory Mutual allow this sprinkler to be used in certain applications. So don't throw it out in a Factory Mutual environment just because it doesn't have the FM approval. Okay, so what do you have new? Glad you asked me that too. Okay, one of the things that we want to talk a little bit about is this model G411. And again, we talked about this idea of these new clean rooms that we're seeing, and where those clean rooms are extra hazard. So obviously something with a large K factor would be incredibly helpful, right? So the G411 is a sprinkler that we think you're going to find some uses for in that environment. Okay. And that's not the only place that you could use it. If you run into situations where you have limited water supplies, or you have some higher densities that don't even necessarily correspond to that extra hazard environment, there's nothing to prevent you from using that sprinkler in those applications either. Yeah, there's nothing special about it in the sense that it is a standard coverage, flat concealed sprinkler. Again, 11.2K. Available in both ordinary and intermediate temperatures, and it is UL listed. So 3 cover plate options, and this is kind of one of those things that I think you need to consider. Okay, and we show this specifically on the bulletin, and I'll show you where that is on the next slide. But if you get the G5 cover plate and you simply use the cover plate for this sprinkler, it is considered a quick response sprinkler. Now, you know that we also make the ceiling type sprinklers that have the gasket around them. So if you use this with a G5 cover plate with a quick response gasket, again, it's quick response gasket, right? Duh. We're going to call it a quick response sprinkler, right? But if you go with a G5 and you use the standard response gasket, then the sprinkler becomes a standard response sprinkler. Okay. So if you're looking for this, we posted this, I want to say it was last week sometime that we actually posted this bulletin. And then you're going to find this, it's Bulletin 086 on the website. And again, this is a table that I'm talking about. If you look at table A, it's going to show you what the classification of the sprinkler is relative to the gasket that you're using. You're going to find that in table A, and a variety of different finishes. And keep in mind that the cover plate in this case is our G5 cover plate. So, if it's again, I think one of the things that Reliable's done really well in the last number of years is, whether it's a residential sprinkler or a commercial sprinkler or whatever, if it uses a cover plate, the G5 is going to be the cover plate that works for that sprinkler for everything except the MRI sprinkler. That's going to be a very specific cover plate that you need to use for that application. Okay, what about FM specific sprinklers? Where are we as far as FM specific sprinklers? Well, again, FM, the beauty of it is it's going to give us some situations where we are allowed to use quick response sprinklers. So the GL112 is a quick response leak sprinkler that Reliable manufactures. It is FM approved as a quick response sprinkler. Standard coverage, and again, ordinary, you're going to find it ordinary temperature. You're going to find it in intermediate temperature, 3/4 inch NPT. And then one significant jump that we take is this idea when we go to FM. Remember, FM takes a look at a sprinkler, and they don't call it necessarily an ESFR. They call it a quick response sprinkler. So that allows us to take some higher K factor sprinklers and use them in an FM environment that is extra hazard. So, the Reliable lineup includes our JL14, our JL17, right? And again, if you're not familiar, anytime you see nomenclature like that in a Reliable sprinkler, it's telling you what the K factor of that sprinkler is. So the JL14 is obviously a 14K, JL17 is going to be a 17K. And then in addition to that, we have the P22 and the P25. Again, K factors of K22 and K25. All of those sprinklers available in both ordinary and intermediate temperature. And then all of those sprinklers also 175 PSI rated. So with that, I will take any questions that you guys have.
Hi, George. We had one particular question in the Q&A dealing with exhausts, specifically going through the roof, as would be perhaps from a spray booth. And the question was, can you use sidewall sprinklers to protect those, or do you need to use a pendant in the sidewall position? I guess, are there any prohibitions?
If there are prohibitions, Alan, I am not aware of them. I know there have been times where I've used sidewall sprinklers in those applications, and again, with no issues. Um, what's your exposure? Because I don't really want to give the wrong answer here. Have you run into that scenario? And what's been your experience?
Yeah, I would just answer you and say back to Andy's question from the Q&A. I have done the same. We have always used, especially at the roof line where you're going to exhaust through the roof, a dry sidewall at that position, just done with some type of access panel so that it obviously can be accessed after the fact if it needs to be taken out for testing after the 15-year now at that point. So I think either way, in my experience, is probably acceptable, but I think a sidewall can be used if that's what the installing contractor chooses to use.
Yeah, okay. Yeah, like I said, that's been my experience. I know that I have used them in the past. So if it's no longer acceptable, that would be a change to NFPA. And if it has changed, I haven't seen it and I'm not aware of it. So I guess that's the best answer that I have. What else you got, Alan?
George, we did not have any other questions in the Q&A. That one from Andy was the only one that popped up.
Okay. Well, great. I guess with that, that kind of wraps up our webinar for today. I do just want to take a minute to tell you that our next presentation will include the very handsome Sam Schwander that you see there on your left, one of our technical service managers here at Reliable, who is going to do this presentation on fluorine-free foams. And he's going to be joined by a gentleman named Maxime from Perimeter Solutions to do that particular presentation. So we thank you all for joining us today. Again, if you have topics that you think you'd like to see us try and cover in future events, please let us know. And hopefully we will see you on our next presentation in June. Thanks, y'all.